Hi, so this is a quick video going through how to set up the Conway's Game of Life simulation within Unreal Engine using Niagara. So this was just a learning exercise and a tech demo to see what's possible with the grid system in Niagara. So I'll be showing you how to get this going, and I'll break it into two parts. The first section is just things you need to set up, and then the second part is the actual logic. So I'll start with the initial setup. So you want to make sure that you've got a render target. I'm using a 256 by 256 size, and it's an 8-bit channel float. So we can go super cheap on this. We don't really need the float accuracy, so we can just go with the cheapest option. And we also need to make a quick material. This just samples that render target we just made, and a seal function to just round it up, because you only care about the cell being either 1 or 0. So this just makes it easy to look at. And once you've got those two set up, we can jump into Niagara. So you can just create an empty emitter and place one of these emitters. And the first thing you want to do is you want to make sure that you create an emitter attribute of a grid 2D collection, and make sure that it's set up to unsigned normalized byte. And you need to also set the resolution. To do so, you can click on this add module button and make sure that library only is turned off. Then you can just search for grid 2D resolution, and you can set the resolution here. So we're going to set it to the same value as our render target. So if you picked a different value, you'd have to match it here. And then the next step is to set up our export render target. This is where we're going to write the actual simulation to. So create an emitter attribute of a render target, and the actual render target is going to be driven by a user input. So in the user parameters, you're going to create a texture render target, and you can create that and then select the render target you want, and you can then drag you actually just select here, and then you select your render target there. So whatever render target you select here is what we will be writing to. So yeah, and in the emitter update, I'm just using once and infinite on loop behavior. And before we get to the logic, you also want to set up a sprite render. Now this is just so that we can visualize the simulation within Niagara itself without having to places in the world. So just create a sprite render and make sure that it's sourced on the emitter so that it just stays forever. And you can put your material here that you created before for just visualizing the render target. So this will just allow you to see it here. So that's pretty much the initial setup. So let's jump into the logic. So the first thing we want to do is create a generic simulation stage and make sure that it's set to data interface and on simulation reset, and make sure that the data interface is the grid that we created. And this simulation stage is just going to be for initializing the starting state that the Conway's Game of Life evolves from. So we can then just jump into a scratchpad, and we're gonna create a grid 2D input and a texture sample. And this is how we sample the texture based on the cell of the grid. So we get the corresponding cell to the corresponding UV, and we get that value, and we quickly calculate a rough luminance, and we compare if it's above 0.5, we return 1, if not 0, and then we store that into a state attribute. Now if we change the namespace to start context, this is then stored into the actual grid itself. That's how we store it there. So also make sure that in your grid, in your scratchpad, you set the grid collection that we set up here as your grid. And yeah, you can then set the texture that you want as your initial starting state. So the next part is the logic. So this is another generic simulation stage. It's a data interface that loops through the grid. Make sure that it executes on always. And we can jump into the scratchpad. So this uses some HLSL code, but I'll quickly go through what it's exactly doing here. So we get in our grid and we are just checking the stored state from the current cell and the surrounding cells, and then we do some sort of comparison to apply the Conway's game of life rules, and then we write in the new state based off of those rules, and then we loop again, and this is how we evolve the simulation. So this is pretty much what this code is doing here. Pretty much just reading all those states from the different cells, and we know based off of unit that we get here where we are at in the grid, and we can just sample that to get self, but to get the surrounding ones we've got to offset the unit by these vectors, which just correspond to the direction that we want to look at. And yeah, that's how we read the surrounding cells, and then we can just count how many of those are on, and then we can adjust our own state based off that. So that's the basic rule set to that. Also make sure that you've got the grid attribute here as your input, and we can move on to writing to the render target. And here we do it by creating another generic simulation stage that uses a render target. Our render target as the data interface, set to execute always, and we can jump into the custom scratchpad. So here we get in a grid 2D collection and a render target, and this is how we read the stored state in the grid. We get execution index to unit, and then we read the specific attribute that we want, and we're then setting that to the render target, which will be pulled in from here. And exec to index just gives us the current pixel that we're working with, that we're writing to, and this is how we write the grid values to the render target. And yeah, that's pretty much what we're doing here, and this should give you this result you see here. This will be in, I'll provide the project files for this so you can take a deeper dive into how this is working. But one thing I like to do when dealing with this is to set a fixed tick delta time, because if you leave this uncapped, the simulation runs just as fast as possible, and you can start seeing some blurring here, especially if you've got TAA. So yeah, I like to just limit this to some larger value so that it feels more snappy and less blurry. So yeah, that's pretty much it, and I hope this has been helpful.